in agricultural research, extension, and education. The NCFAR seminar series has featured and does feature leading-edge researchers discussing their work towards meeting 21st century challenges and opportunities, and it hopefully demonstrates the value return from public investment in research, as well as providing timely information to you all that may prove useful in your own work. I would like to thank the contributing sponsors whose financial support makes these seminars possible. So the NCFAR has sponsored over 150 Lunch and Learn seminars on the Hill, all of which have been in person until today. As we're all dealing with COVID-19 and safe distancing practices, we're using this webinar approach to continue serving as a resource to Hill staff, agency officials, and other interested stakeholders until we're able to meet again in person to share knowledge, as well as that ever important lunch part of the Lunch and Learn. A couple of housekeeping items to help ensure the quality of this presentation. All of the attendees' microphones are on mute. You're invited to pose your questions through the chat function on your screen at any time during the webinar. My colleague, Lauren Broccoli, is monitoring the questions, and we will work through as many as we have time for at the end of the presentation. We would also welcome your feedback about this virtual seminar approach. We are committed to ending this program on time as advertised out of respect for your busy schedules. We've asked our speaker to finish his presentation by about 12:40 or so, which should allow about 15 minutes for questions and discussions afterwards. Having said all that, it's my privilege to introduce our speaker, Dr. Hans Coetzee, professor and head of the Department of Anatomy and Physiology at the Kansas State University College of Veterinary Medicine. Dr. Coetzee has been the recipient of several federally funded grants, and today will describe his work related to a USDA grant to improve agricultural animal well-being, a topic not only of interest to us at the AVMA, but also to the public at large. And with that, I will turn the floor over to Dr. Coetzee. Welcome, Dr. Coetzee.
Thank you, Dr. Murphy. I appreciate the introduction. I'm going to start sharing my screen. Thank you. I assume everyone can see my screen at this point. Is that correct? Dr. Murphy, can you very good. Thank you.
Good to go. Yep.
I appreciate the opportunity to visit with you today about some research that we've been engaged in the past 10 years or so that has been largely supported by the USDA NCFAR program. The focus of our research has been how do we advance animal well-being with improved methods to recognize and manage pain in livestock. To begin with, I'd like to share some funding disclosures. The majority of our research, as I mentioned, was being funded by USDA. In addition, I've served as a consultant for various livestock pharmaceutical companies. I've also engaged and sponsored continuing education at both the local and state veterinary medical association level. And I am an inventor or co-inventor on 2 patents specifically related to the providing analgesia and pain management in cattle and pigs. And all the studies that I'll share with you today have received ethical oversight from our local institutional animal care and use committee. The focus of our presentation today will be to address 4 questions. The first is why pain management in farm animals is important. The second will be a brief discussion about some of the barriers that exist to the widespread implementation of pain management strategies in livestock. I'll then share with you some of the new advances in pain assessment and pain management in livestock species, primarily cattle and pigs. And we will finish the presentation with a brief discussion of some of the unmet pain management needs in livestock production. To begin with, I'd like to discuss briefly some of the pain challenges that we encounter in livestock production systems. And these can be broadly categorized into 2 areas. The first is pain associated with elective procedures, and the second will be pain associated with livestock management. In regards to pain associated with elective procedures, some of the more commonly practiced procedures on livestock production systems include castration, tail docking in pigs and sheep, dehorning primarily in calves and goats, and then branding mostly in the western states for identification purposes, abdominal surgery, and beak trimming in poultry. In regards to the pain associated with livestock management, our focus has been to study conditions such as lameness, in addition to calving, lambing, and farrowing, and some infectious diseases, most notably infectious lameness and bovine respiratory disease. One of the questions that we commonly are asked when we have conversations with consumers are why are these procedures necessary in livestock production systems? And so briefly, castration is important from the perspective of reducing aggression amongst animals, which helps to prevent injury when we commingle animals from different groups. And more importantly, castration is significant from the point of view of reducing the risk of unplanned breeding events that may occur within the production system. And from a meat quality standpoint, castrated male animals have improved meat quality compared to uncastrated or intact animals. In pigs, castration is very important from the point of view of reducing a condition known as boar taint. Boar taint is an unpleasant taste that occurs during the cooking process when cooking meat from non-castrated male pigs after they reach puberty. And so by castrating these animals, we will reduce that unpleasant taste or unpleasant odor that arises in those animals. Dehorning is also commonly conducted on livestock production systems to reduce injury to other animals and also risk to caregivers. And branding, as I've mentioned previously, is more widely used in the western parts of the United States for animal identification. So these procedures are all commonly part of what's known as processing on production systems, which are designed procedures to try to reduce the risk to the caregiver and to the animals themselves. Pain management is a critical component for farm animal welfare. And on this slide, I've represented two of the common constructs that we use to assess animal welfare in production animals. On the left are the 5 freedoms. Many would be familiar with if you've read about farm animal welfare. And this was first proposed in 1965 in the United Kingdom in the Bramble Report. And listed amongst the 5 freedoms is freedom from pain, injury, and disease. And so when you subscribe to the construct of the 5 freedoms, a critical component of that to assure animal welfare is to bring about freedom from pain, injury, and disease. The second construct was proposed by David Fraser from the University of British Columbia, and David had proposed these 3 spheres that intersect at the point which represents good welfare. And those 3 spheres are basic health and functioning, natural living, and the affective states. When we talk about pain and pain management, we're really focused on the affective states. And so ensuring good welfare requires producers to take note of pain and to bring about pain management strategies within their productive systems to assure animal well-being. Providing analgesia at the time of processing in livestock is becoming an expectation for raising livestock. And it is a component of good welfare, as illustrated by these numerous certification programs that are prevalent across the United States. And many companies, such as Starbucks, for example, have taken a position on assuring farm animal welfare practices. And specifically, they have called upon producers to address concerns related to dehorning, tail docking, and castration, both with and without anesthesia. And so this has become an increasing expectation for livestock producers to address. And so the focus of our slides moving forward here is some of the efforts that have been made in order to comply with these regulations in order to assure that livestock welfare needs are met through the provision of pain management. So food processors and retailers have responded to these increasing concerns about pain in livestock by directly addressing this with producers. This was a letter that was circulated to livestock producers in 2014 from Tyson Fresh Meats. And in this letter, Tyson encouraged producers to adopt practices that reduced or eliminate the pain associated with procedures such as tail docking and castration. And this included the use of anesthetics or analgesics that were approved for use or permissible under the Animal Medicinal Drug Use Clarification Act, known as AMDUCA. Now, the challenge that livestock producers face in addressing this expectation is that currently we have no drugs that are approved by the United States Food and Drug Administration that are specifically labeled to relieve pain in pigs. And so as a consequence, livestock producers under the direction of their veterinarians address this need through the Animal Medicinal Drug Use Clarification Act, and all such activities constitute extra label drug use, which I'll address in an upcoming slide. In addition, producer organizations have also responded to the increasing concerns about pain in livestock, specifically the National Dairy Farmers Association, and their farm program has provided a framework for farm animal care that represents about 98% of the U.S. domestic milk supply. And in the most recent version of the farm program, pain mitigation is expected to be used when disbudding calves using any method of disbudding, whether it's paste disbudding or rotary disbudding, and producers are expected to work with their veterinarians to determine the most appropriate pain mitigation strategy at the time of disbudding. But again, it's noteworthy that currently we have no FDA-approved drugs specifically labeled to relieve pain after disbudding. So once again, producers and veterinarians have to rely on the framework provided by the Animal Medicinal Drug Use Clarification Act, or MDUCA, in order to use pain relief drugs in an extra label manner to alleviate pain associated with disbudding. We recently completed a survey of livestock producers that was specifically, and veterinarians too, that was specifically focused on assessing attitudes towards pain management in cattle, and how those attitudes may have changed over the last 10 years. We had conducted a similar survey in 2008, and this was a follow-up 10 years later. And we had 1,187 respondents to our survey. And what was interesting is that we found in the last 10 years that 57% of respondents, or 679 respondents, indicated that their use of analgesic drugs had increased in the last 10 years. Whereas 36% had indicated that their use had stayed the same, and only about 5% had indicated that pain management use had decreased in the last 10 years. What was especially noteworthy in the survey is that 3/4 of respondents agreed that cattle benefit from receiving analgesic drugs as part of their treatment, and only 1/3 of those respondents thought that analgesics may mask deterioration in the animal's condition. Overall, approximately half the respondents agreed with the statement that the benefits of analgesia outweigh the costs, but significantly, almost 2/3 of those respondents agreed with the statement that current FDA regulations limit their ability to use analgesic drugs in cattle. And so this has been the focus of our research, is how to address this urgent need for approved analgesic drugs to be used on livestock production systems. So secondly, we're going to focus on some of the barriers associated to the widespread adoption of pain management in livestock production systems. And the first and probably the most major challenge is that we have some issues with trying to assess pain in livestock. Most of our livestock species are very stoic. Many of them evolved from prey animals, and so those animals don't tend to show signs of pain significantly when we try to assess their behavior. And so that has made it quite difficult for us to be able to come up with pain assessment tools needed to be able to get analgesic drugs approved. The second issue, as I've mentioned already, is that we currently only have one drug that is specifically approved for pain management in cattle, and that compound is only approved to alleviate pain associated with infectious lameness in cattle. So currently, we have no drugs that are labeled for alleviating pain associated with castration and dehorning in cattle, and we have no compounds labeled for pain management in pigs. And so this has created some significant challenges for producers and veterinarians because they have to operate under the constructs of MDUCA. Furthermore, there's oftentimes a time delay between drug administration and the onset of activity of the drug, and this requires repeated handling that increases labor costs, and it's just not convenient for livestock producers to administer these drugs when they require repeated handling events. Similarly, some of the drugs that we would typically use for pain management have inconvenient routes of administration, and so these have to be injected either intravenously or intramuscularly, which can be challenging in some livestock production systems. The drugs we could potentially use for pain management also tend to have a short duration of activity, and in some cases there's a cost associated with the drug or its withhold period, which may serve as a disincentive for a producer to use the drug in a production system. The other challenge that we have, similar to in human medicine, is that we have nothing that works particularly well for treating chronic pain conditions such as lameness. And so all of these aspects or these considerations have played into the challenges or barriers associated with the implementation of pain management protocols in livestock. So one of the more common questions that we encounter is why the approval of pain management drugs for livestock has been challenging. And specifically, we point to an FDA guidance document, Guidance 123, which outlines the specific requirements that would be necessary in order for a drug to be labeled to alleviate pain. And these guidance documents are a recommendation. They are not a legislative requirement. So these just provide a guideline or an outline for a pharmaceutical company on how they would approach having a drug approved for pain relief. And specifically, in order to have a drug labeled for pain management, the FDA recommends that this indication be based on the control of clinical signs of pain associated with the disease. And FDA encourages the use of validated methods of pain assessment in the target species. And so in the next few slides, we're going to discuss what constitutes a potentially validated method of pain assessment, and we'll discuss some of the ways in which we've approached the use of those technologies to move towards a situation where a drug could be approved to alleviate pain in livestock. So currently, within the constructs of the Animal Medicinal Drug Use Clarification Act, or AMDUCA, any use of a pain relief drug that is off-label constitutes what's known as extra-label drug use. And under the requirements of AMDUCA, all of these drugs have to be prescribed by a veterinarian. The use of that particular pain relief drug must be manufactured in an FDA-approved facility. The producer has an additional regulatory burden of having to keep accurate records of all instances of extra-label drug use. Extra-label drug use is also not permitted in feed, and the veterinarian is also responsible for providing withhold period recommendations for those drugs when used in an extra-label manner. And so this has produced an additional regulatory burden on the veterinarian when complying with AMDUCA when they use drugs in an extra-label manner to alleviate pain. And so the short answer is that we really need to have drugs that are specifically labeled for pain relief in order to reduce the requirement for these practices to occur under AMDUCA in an extra-label manner. So the next few slides will focus on how we actually determine whether the use of whether use of analgesic drug is indicated by determining whether a particular procedure or process is painful in the animal. And this research was primarily supported by NCFAR in a grant that was awarded in 2008. Currently in human medicine, there is increased reliance on these visual analog scale tools. And anybody on the call who has been in hospital recently would have been asked the question on a scale of 0 to 10, how much pain are you in? And typically the response that represents a 10 would be the worst pain imaginable, and a response that represents a 0 would be no pain. And in this particular adaptation, this is known as the Wong-Baker Facial Grimace Scale. They use this in pediatric patients to determine whether a pediatric patient is in pain or not. And these scales have been widely used in order to bring about analgesic drug approvals for use in human medicine. The challenge that we've had in veterinary species is that many of our animals do not demonstrate signs of pain in the same way as we would expect to see in people. And these stoic species are very challenging to assess pain in because they tend to conceal those signs of pain based on the way that they've evolved. So some of the tools that we have focused on to try to assess pain in livestock are listed on this slide. And those that are outlined in red have proved to be not particularly useful to assess pain, and these include electrodermal activity, which is assessing electrical conductance in the skin of the animal. The speed at which the animal leaves the production facility, or the chute exit speed, has also been assessed and found not to be very useful. Assessment of growth and performance is also unreliable, and the use of accelerometers to assess animal movement also has some challenges associated with it. Some of the outcomes that we've used that have been more successful in assessing pain include the assessment of behavior or location in a pen, the assessment of heart rate in the animal to determine changes in heart rate associated with pain. We've also assessed various blood-based biomarkers, including the stress hormone cortisol and a pain neuropeptide called substance P. And then some of the more successful outcomes that we've measured include the use of EEGs to assess brainwave activity, the use of pressure algometers to assess tolerance to increasing amounts of pressure at a surgical site. And then the most successful tools have been the use of thermography to assess changes in skin temperature, and the use of pressure mat technology to assess changes in how the animals walk. And so changes in gait have proven to be a very useful tool to assess pain associated with lameness and other conditions in production livestock. So I'll focus a little bit about the use of thermography. And so thermography is a system to detect changes in skin temperature associated with changes in blood flow to the surface of the skin. So when an animal is in pain, there is the release of epinephrine, which is one of the fight or flight response hormones that's released by the animal when the animal experiences pain. And that epinephrine causes the blood vessels in the skin to contract, and that directs blood away from the skin to the central organs to allow the animals to cope with that stressful situation. And in doing so, the skin temperature drops. And we can use these thermography cameras very successfully to measure quantifiable changes to localized body temperature, and to measure and study these using some sophisticated research software. So in the next slide, I'm going to show you a video clip of an animal that is experiencing a surgical castration procedure. And if you focus especially on the temperature change around the eye, you'll observe what happens when this animal experiences pain. So we start off with the color being predominantly red, and then we see the painful process occurring, and the skin temperature changes very rapidly to yellows and greens, indicating that the blood vessels in the skin have contracted and is directing the blood away from the skin to the central organs. And this research was directly supported by the USDA grant we received in 2008. So I'll show this video clip again because it's very interesting to see how quickly that body change occurs, especially around the eye. So if you focus around the eye of the animal, you'll see as soon as the surgical castration procedure occurs, the blood vessels contract right there, and you'll see how the skin temperature changes to yellow and green, indicating that blood flow to the skin has changed in response to that painful procedure. And we were able to study that and measure that using some research software. We've also published the use of thermography to assess pain in piglets. In this particular experiment, we administered the pain relief drug to the sow, and she then passively delivered the drug through her milk to the nursing piglets before they were processed. And at the bottom of the slide here on the left-hand side, you'll see a piglet. And if you focus specifically on the head of the piglet, you'll see that the color is predominantly dark red, indicating good blood flow to the surface of the skin. Whereas the piglet on the right, you'll notice the head temperature of that skin is predominantly green and yellow, indicating a much lower skin temperature of the head. And those piglets represent piglets that are nursing on sows that received the pain relief drug, which is the piglet on the left, and piglets that were nursing on sows that did not receive the pain relief drug, which is the piglet on the right, before the piglets were processed. And this processing procedure was a surgical castration. So the graph represents that graphically, whereas the blue line is the head temperatures of the piglets that were nursing sows that received the pain relief after they were processed, whereas the red line represents the piglets that were nursing sows that did not receive the pain relief. And you'll note that there were higher skin temperatures observed in the piglets that were nursing the medicated sows compared with the sows that were not medicated. And so we've demonstrated that this thermography technology is an extremely useful tool to try to indirectly assess the pain experienced by the piglets And we've demonstrated that the use of a pain relief drug, in this case, a drug delivered in the milk to the piglets, can actually be quantified by measuring the head temperature of the piglets nursing the medicated sows versus the piglets that were not nursing medicated sows at the time of processing. In addition, we've also assessed brain wave activity in livestock, in this case, particularly cattle, at the time of surgical castration. And this electroencephalography or EEG technology is similar to the technology that's used to assess brainwave activity in human medicine. And this has been used to assess the effect of age and method of castration and the impact of pain relief drugs on the central processing of pain in livestock. And so these are cattle that were not anesthetized or sedated, but they were acclimated to stand in these facilities to allow us to assess changes in the electrical activity on the surface of the scalp using the EEG technology that's used in human medicine to assess brainwave activity. So in this particular slide, this represents the EEG waves generated from calves that were 6 weeks of age at the time of surgical castration. And so the brain waves that we measure are represented in the top right-hand corner of the slide. And what I want you to focus on primarily are two types of waves. The first are the beta waves, and you'll see that those are waves that are tightly compacted together, and those are predominant when animals are anxious or alert. Whereas if you contrast that with alpha, theta, and delta waves, in this instance, the waves are further apart, and these are represented in animals that are relaxed, drowsy, or sleepy. And so typically when we measure this type of activity, in this case in the 6-week-old calf, the red line here represents the approximate point of surgical castration. And that you'll notice on the right side of the red line, which is after the procedure has occurred, we do not see very significant changes in all of the leads compared with the brainwave activity observed on the left side of the red line. So the red line being the approximate point of castration, we see that change in brainwave activity that occurs, but it's not very significant in these younger calves, suggesting that they don't process the painful procedure to the same extent as an animal that is older. So the next slide is 6-month-old calves that were also subjected to a surgical castration procedure. And you'll notice that beyond the red line on the right side of the red line, that we see very significant changes in the brainwave activity occurring in these animals after surgical castration. And so the take-home message that we communicate to producers based on this research is that we want to try to perform these procedures at the earliest age practicable. It does not suggest that the procedures are not painful in those younger animals, but it does suggest that those animals may not process the pain to the same extent as older animals, and so that it would be preferable from a management perspective to be able to focus those painful procedures on a younger animal as opposed to an older animal. And so this EEG technology has proven to be very useful to demonstrate to producers the value of implementing these management practices earlier in the animal's life as opposed to waiting until they're much older. The last piece of technology that I wanted to highlight is the use of pressure mats. And so pressure mats are a walkway with sensors in the mat that we can capture using computer software technology, assessing exactly the characteristics of the animal's gait as they walk across the mat. And so these pressure mats allow us to assess the duration of the stride, the length of the stride, the amount of force that the animals apply to the stride, and the way that force is distributed. And so essentially by using the pressure mat, we can completely characterize how the weight is distributed and how the animal walks across this particular mat. So this technology was actually the primary objective endpoint that was used in the securing of the first analgesic drug approval in the United States. And this was for a drug called banamine transdermal that is approved for alleviating pain associated with infectious lameness in cattle. And so this particular technology that was supported through the USDA funding that we received. It proved to be a validated method of pain assessment in these animals, and the calves that received the flunixin had a higher force and a greater amount of contact area as assessed by the pressure mat compared with calves in the control group that did not receive any pain relief. And so the calf that you can see in the video clip crossing over the mat here was subjected to an induced lameness, which is a very transient lameness. It's a very short duration. And so even though it appears painful in this particular slide, this was a very short duration and allowed us enough time to be able to assess the pain in the animal and then to rescue the animal from the lameness using a pain relief drug in order to ensure that its welfare was not compromised. So these types of reversible lameness models are extremely useful to us to be able to understand how the analgesic drugs are working and the effect in the animal. And so once again, those federal dollars that we received proved to be extremely useful in assisting us in validating a method of pain assessment that ultimately led to the first analgesic drug approval for use in livestock in the United States. We've also used this technology to assess lameness in pigs. And so if a pharmaceutical company had interest in pursuing an analgesic drug approval to alleviate lameness in swine, this technology could be a part of an assessment package to determine if that drug is effective or useful in those animals. Currently, we're also doing studies looking at genetic biomarkers for pain detection. And this particular graph on the slide demonstrates gene expression on the x-axis and the difference in fold change expression of those genes in response to pain associated with a transient lameness model. So again, an induced lameness that lasted for a short period of time. And the red graph here is the pain effects. These were gene expressions that occurred in animals that did not receive any analgesia. The yellow graph represents the control animals, and the green represents animals that received pain relief. And so you'll note from the increases in expression associated with the green animals that received pain relief, those were substantially less than the animals that were in the red group, which did not receive pain relief. And so we're excited about the prospect of this technology being useful not only in animals, but also potentially in people to try to objectively assess pain, especially in nonverbal patients where pain assessment can be very challenging. So this genetic expression profiling is continuing in our lab, but promises to potentially be a very versatile tool moving forward. So to finish up in this presentation, what I'm going to focus on in the next few slides is what we can do to try to minimize pain in livestock. And we use what's known as the 3 S's approach. And so the 3 S's stand for suppressing the source of pain, for substituting a particular procedure with a less painful alternative, or soothing the animal with an analgesic drug. So the 3 S's are suppress, substitute, and soothe. And so various studies are ongoing to try to reduce the need for conducting these painful procedures. And one of those includes the use of polled genetics to try to eliminate the need for dehorning. Polled essentially means an animal that doesn't have the gene to express the development of horns. And through the use of gene editing technologies, we're able to change the genome of those animals so that the gene that expresses the horn is no longer present. And so those animals are born without horns. In addition, in the dairy industry, there's ongoing research that's looking at the use of sexed semen to reduce the need for castration by only having female calves that are born on the production system and not male calves. In addition, there's research ongoing in the swine industry to try to select for reduced boar taint in pigs. In terms of substituting with a less painful alternative, one of the approaches here is to optimize the timing of the procedure, as I demonstrated with the slides that represented the EEG outcomes in calves. Optimizing timing could be conducted to reduce the painfulness of the procedure by conducting that procedure earlier in the life of the animal. And we're also conducting some research with support from USDA to develop an immunocastration vaccine that I'll share with you in an upcoming slide. And then the last approach, as we've discussed here this afternoon, has been the use of pain relief drugs to alleviate pain. But the constraints there are obviously, from a livestock production perspective, is that pain relief drugs obviously have to be cost efficient for the producer to use and also convenient for them to administer in order for these practices to become routine in a livestock production system. So I want to share with you in the next couple of slides some of the studies that we've conducted to lower the barrier to on-farm analgesic use in livestock production systems. The first technique we developed with USDA support was to discover that a drug called meloxicam, which is a prescription-only non-steroidal anti-inflammatory drug used to treat arthritis in people, is also extremely effective to treat pain in cattle and pigs. These meloxicam tablets, although they are approved for use in humans, can legally be used in cattle under AMDUCA, and they are rapidly absorbed from the gut of the animal and provide effective pain relief for several days after a single dose. And so the producer does not have to administer the drug repeatedly. A single administration of the drug is effective to alleviate pain associated with dehorning and castration. And these human generic tablets are also very inexpensive. It costs less than 10 cents to medicate a 100-pound calf using these meloxicam tablets. And so we typically take the human tablets, we administer them in one of these large plastic capsules that are made of gelatin. And these capsules can be administered orally to the calf, which is a relatively stress-free way to administer the drug, especially given the fact that it lasts for several days after a single administration. In our experiments with meloxicam, we've demonstrated two key endpoints for livestock producers. The first is from a behavioral perspective. In this particular study, we had 6 calves in the experiment, and you'll notice that we have 3 calves that are up here at the feed bunk eating, and there's some calves in the back of the pen that are laying down that are not up and eating at the feed bunk. And it turns out that these 3 calves that are at the feed bunk are calves that received meloxicam. And so from a behavioral standpoint, they're demonstrating very few signs of pain, whereas the animals here in the back of the pen did not receive any analgesia, and they're obviously not eating or performing as they should be. And so from a behavioral perspective, producers can very easily see the benefits of pain management just within this group because they are very familiar with the animals and they care about those animals. They can see that these animals are benefiting from the receiving pain management. We also demonstrated in this experiment that those animals had improved average daily gain or improved growth rates compared to animals that did not receive the meloxicam. And so in this slide, you can see here this bar of the chart demonstrates the average gain in kilograms of the calves that received the pain relief versus the calves that did not. Interestingly, we also demonstrated in a subsequent experiment that the use of pain relief reduced the number of animals that required antibiotic treatment for bovine respiratory disease. And so in this graph, the red line represents animals that were processed or castrated without pain relief, whereas the blue line represents calves that were processed with pain relief. And the y-axis here represents the cumulative percentage of animals that required antibiotic treatment, whereas the x-axis represents the days to the diagnosis of bovine respiratory disease or pneumonia. And so this graph very clearly indicates that the animals that receive pain management, about half the number of animals required treatment with an antibiotic, compared with the animals that did not receive pain management. About 40% of those animals required treatment with an antibiotic. So from an antimicrobial stewardship perspective, the use of pain management may also have benefits for the production system in reducing the reliance of the producer on antibiotics to alleviate some of the conditions or circumstances associated with stress after processing that include the development of bovine respiratory disease. As I mentioned previously, we also have increased the convenience of administering pain relief drugs to piglets by medicating the sows. And in so doing, we also have lowered some of the barriers to on-farm analgesic use. Through transmammary delivery of a pain relief drug, it reduces the need to inject every piglet individually before the surgical procedure is performed. It also reduces some of the stress on the caregivers at the time of processing because they only have to handle the piglets once. There's also fewer needle sticks involved, so it's less stressful for the pigs and for the workers. And because the drug is continuously delivered through the milk from the sow to the piglets, it is also potentially long-acting and long-lasting. And we also have shown in a subsequent study that piglets that are nursing on sows that receive medication have improved growth rates compared to piglets that are not. And so this may also potentially have a production benefit for a livestock producer in addition to having an animal welfare benefit to the piglets. We also are currently investigating several non-pharmaceutical alternatives to reducing pain in livestock, and one of these supported by USDA is the development of an immunocastration vaccine. And through the use of one of these vaccines, we are fulfilling one of the 3 S's by substituting surgical castration with a less painful alternative, in this case a vaccine that causes the animal to develop antibodies against some of the hormones that are responsible for the development of the male reproductive system. And in doing so, it would eliminate the need for surgical castration. These implants are inserted under the skin of the ear, and they produce antibodies over the lifetime of the animal. And so in doing so, it also reduces the need for each individual animal to be injected, and so reduces the risk to the operator of accidental self-injection. So these immunocastration implants potentially have a dual benefit of improving the welfare of the animal and also reducing the risk to the caregiver to perform some of these procedures that are considered dangerous on livestock production systems. So this is potentially an area where we could see some benefit in the future from an animal welfare perspective. And finally, we're also investigating the use of surgical castration using a carbon dioxide laser system as opposed to a scalpel. And these laser surgery units are very commonly used in human medicine and are considered to be less painful and also result in reduced duration of wound healing in humans compared to a conventional surgery with a scalpel. And we're currently investigating the use of these laser surgery units in pigs as well as a potentially less painful method to perform processing procedures such as castration and tail docking. Finally, to finish up, I wanted to emphasize some of the unmet needs for pain management in livestock. And as I've mentioned on several occasions during this presentation, we currently do not have any drugs with FDA approval to relieve pain in pigs. We also currently do not have any drugs with FDA approval to relieve pain associated with castration, dehorning, and branding in cattle. And in order to obtain these approvals, we have to identify and validate additional robust pain biomarkers. And our focus primarily has been on some of the genomic markers that I mentioned previously. The primary unmet need, in my opinion, is the absence of analgesic drugs approval that places this regulatory burden on veterinarians and livestock producers who now under AMDUCA are responsible for ensuring that drug residues do not enter the food supply. And so this continued use of extra-label drug use is not sustainable for livestock production systems. And so we urgently need drug approvals in order to address this need. One of the interesting initiatives that is underway was the formation of the Pain Mitigation Consortium under the leadership of the American Association of Swine Veterinarians and the National Pork Board. This consortium was established to address the need of the absence of analgesic drugs for use in pigs, particularly piglets at the time of processing. And the consortium is a collaboration between industry partners, the United States government, specifically the Food and Drug Administration, and several research and academic institutions, including Kansas State University, Iowa State University, North Carolina State University, the Prairie Swine Center in Canada, and Ag Research in New Zealand. So together, this tripartite consortium is focused on trying to address some of the barriers associated with analgesic drug approval, specifically in piglets at the time of processing. So the overarching goals of our consortium are to identify and validate behavioral, physiological, and biomarker-based endpoints that reliably measure pain associated with surgical castration in piglets in both a research, good clinical practice, and an on-farm environment. And this is primarily focused on optimizing the collection methods of these data, of identifying the optimal timing of sample collection, and the best analytical approaches to validate these endpoints. The overarching goal of our consortium is to collaborate with FDA, pharmaceutical companies, and researchers to analyze and interpret these results to eventually develop and publicly disseminate a protocol that could be used by the pharmaceutical industry in order to obtain analgesic drug approvals. So thank you very much for your time and attention this afternoon. I've really appreciated the opportunity to visit with you and share with you some of the research that we've conducted. And just to highlight some of the take-home messages of our presentation today is that I believe considerable progress has been made in validating methods of pain assessments. So with the financial support from USDA and other entities, we've made progress towards developing validated and robust biomarkers in livestock that can be used to support analgesic drug approvals. We've also, with the support, identified oral meloxicam as a convenient and cost-effective approach to providing pain management or pain relief in livestock. In addition to these, we still continue to have an absence of analgesic drug approvals in food animals. And as the use of pain management is a rapidly evolving expectations from consumers, the absence of these FDA-approved analgesic drugs for use in livestock continues to be a significant barrier to the widespread adoption of pain management protocols on farms. So potentially some incentives such as waiving the ADUFA user fees, ADUFA being the Animal Drug User Fee Act, user fees may encourage pharmaceutical companies to pursue analgesic drugs approvals in livestock. And we also urgently need to find some alternatives to painful procedures. And this is also an area of ongoing investigation within our group and others across the U.S. I'd like to acknowledge the financial support that we've received, as I mentioned, from several entities, primarily the USDA, National Institute for Food and Agriculture, but also the National Pork Board through the Pork Checkoff program, the American Association of Bovine Practitioners, and the American Association of Swine Veterinarians through their respective foundations, and also Kansas State University for their continued support of our research. And with that, I'd like to open the floor for questions. And again, I greatly appreciate your time and attention this afternoon and joining us for this discussion. Thank you.
Thank you, Dr. Coetzee. I think I hear a virtual round of applause for you happening right now. So as Dr. Coetzee mentioned, we will take your questions through the chat function. So please continue to posting those. We'll work through as many as we have time for. Dr. Coetzee, I'll start with this one. Based upon your research, I can definitely see the value of these pain measurement modalities for using for in the approval process for new analgesic drugs. But on the farm level, can you tell us, what you think the most reliable way to measure pain is in livestock, and particularly, what the cost of that system would be in use, and is it something that you think producers can do?
Thank you for that question, Dr. Murphy. I think that's a very important point, is that many of the modalities that we've focused on have been to try to fulfill the requirements of analgesic drug approval. But on farm, there's a critical need for producers to be able to identify which animals require pain relief. And given the close relationship that exists between livestock caregivers and the animals under their care, frequently we find that producers are much better at making the determination of an animal being in pain than we are as a research community, because they interact with those animals every day. They are very skilled at identifying behavioral markers of pain and instituting pain management in response to those signals. In addition, there's some excellent work ongoing looking at the use of facial grimace scales to assess pain. And in this regard, some facial recognition software is under development at several institutions that is designed to maybe potentially provide a smartphone app that could be used to take a picture of an animal's facial grimace, which is basically just a facial expression, and compare it with an established machine learning algorithm to make that determination if an animal is in pain. And that's an area of very exciting research that I feel could be very accessible to livestock producers moving forward. But it is always gratifying and humbling to me when I interact with producers to see how much they care about the animals under their care and how skilled they are at making that determination, even though as a research community, we've really struggled with validating some of these endpoints.
Great. So here's another question. You talked, and alluded to the extra label use of these drugs in food animals, and the potential consequences of that. So how do veterinarians ensure that the extra label use of these drugs do not result in drug residues in meat and milk?
This continues to be a challenge for our profession to address this need for an extra label use with hold period recommendations. But we're fortunate to have the Food Animal Residue Avoidance Data Bank, which is known by the acronym FARAD, which is housed at North Carolina State University, UC Davis, University of Florida, and also at Kansas State University. And FARAD operates a call center with USDA federal funding that takes phone calls or internet inquiries from practitioners and provides specific withdrawal period recommendations based on the published literature. So our group and others have been engaged in conducting what is known as tissue residue studies to characterize the depletion of drugs in food that would potentially go into the food chain. And in conducting this research, we provide data to FARAD, and FARAD models that information in order to respond to the requests they receive from practitioners, either through their website or through phone calls, to provide those types of recommendations. So even though operating under the confines of AMDUCA for extra label drug use can be very challenging for practitioners, we're very fortunate to have that federally funded resource in FARAD to be able to provide us with those withdrawal period recommendations to ensure that the nation's food supply stays secure in these situations.
Yeah, that's great. So it seems like through your presentation, you talked mostly about non-steroidal drugs. Any chance that there are alternative classes of drugs that could be considered or that you've looked at?
That's an excellent question. I appreciate you asking that. Our focus has been on non-steroidal anti-inflammatory drugs because of the accessibility to producers. So even though they have to be prescribed by a veterinarian, they're generally considered to be safe and effective with very limited abuse potential, which is why that is a class that we've primarily focused on. Certainly opioid drugs are extremely effective pain relief drugs, but concerns about them potentially being abused limits their utility on livestock production systems. And so we've been limited in our ability to use opioids in food animals. But there are some additional classes, one of which is a drug called gabapentin that we've studied extensively, and many of those on the call may be familiar with its cousin pregabalin, which is marketed as Lyrica. And we found gabapentin to be extremely useful for treating chronic pain conditions such as lameness in cattle. And this is, again, an area where an approval would be extremely useful to the industry if we had a drug such as gabapentin that could be made available to producers to treat those chronic pain conditions. Our group is also researching some alternatives, particularly the cannabinoids. We're looking at CBD as a potential option for pain relief in livestock. We're at the very early stages of that research program and have no data at this point to share. But those alternatives are obviously very attractive to us, potentially for use in livestock systems, and this is an area of ongoing research.
So it seems like you're really comprehensively looking at the spectrum of possibilities. And just for me personally, question for me personally, because I barely remember, as far as opioid use in cows, they're very sensitive to it, aren't they? Just like cats are?
Yes, they are. So one of the challenges we run into, especially ruminants, so food animals, particularly cattle, is that they have some sensitivity to opioids, and it can also cause rumen stasis, which means that the stomach doesn't work as well. And so their effects are also extremely short-lived, and so we tend to have to use higher doses to be effective in ruminants. And so that poses an additional set of challenges for producers and veterinarians, is that you have the potential for some adverse effects on the digestive system of the animal, in addition to the need for a very high dose in order to get the drug to last for long enough for it to actually have some utility And so those are challenges that we continue to face.
Okay, I think we have time for another one or two questions. How about this one? The increased use of pain relief drugs in production, how will that affect the cost for the producers? And towards the end of your presentation, you showed an interesting slide about using the use of analgesics in calves that were being processed, and it was associated with decreased antibiotic use. So maybe as part of the response to the, what costs for producers, is that decreased antibiotic use, would that translate to kind of a zero-sum cost for producers if they spend money on analgesics but less cost on antibiotics? Would they kind of break even on that exchange?
That's certainly an area that we continue to investigate, and it seems like certain classes of animals benefit more from receiving pain relief than others from a production standpoint. So not from a pain perspective, but from a production perspective, it seems that cattle that have been transported over distance that are under stress to begin with will respond much better to the receiving a pain relief drug versus animals that have been acclimated, or what we call preconditioned to the production system. Their response may not be as dramatic in those animals. But certainly cost is a concern for livestock producers in addition to convenience. And inevitably, widespread use of pain management will be an additional cost of production. But our goals, certainly from a research perspective, have been to try to identify reasonable alternatives or inexpensive alternatives. And that's why the focus has been on generic meloxicam tablets, because they are relatively inexpensive for a producer to use, and especially on a larger scale, those types of drugs can be very effective because they last for several days after a single dose. So I think if we have drugs that are designed around the needs of the producer, we can be very effective or very purposeful at developing options for the producer that do not significantly add to the cost of production. So we can offset some of the costs through some health benefits and performance benefits, but the others can be offset through the convenience of administration, so that it becomes something that the producer is more inclined to use routinely.
Well, Dr. Coetzee, I think this was a timely discussion. I appreciate your efforts in this area. Really, I don't see any more questions at this time, and we are out of time. So I'd like to thank you for your presentation today. I'd also like to thank Jean Blankenship and the Academy of Nutrition and Dietetics for the technological support of today's webinar. We hope this webinar has provided information of interest and value to you. This presentation will be available at the website of NCFAR, which is ncfar.org, all small letters, no breaks. And we invite you to watch for invitations to future seminars. The next scheduled seminar from NCFAR will be on June 8th. The speaker will be Dr. Ken Wagner, past president of the North American Lake Management Society and an expert on harmful algal bloom management. So that concludes our program. Thank you for your interest and attention, and have a great afternoon.